Day 135, Electrostatics Homework Example number 39. We have three capacitors. We need to find their equivalent capacitance. That's pretty much the easy part. Here, if we look at it close enough, the 2 and the 4 microfarad capacitors are in series. So we'll combine them by the rule 1 over C total, or 1 over C equivalent, equals 1 over 2 microfarads plus 1 over 4 microfarads, and if you do the math there, that comes out to be 1.33. The combined capacitance is 1.33 microfarads. So you need to draw that diagram. Here it is. I've replaced the 2 and the 4 microfarad capacitors with their equivalent capacitance, 1.33 microfarads. Now we have two capacitors in parallel. That's the easy computation. If you just add those two up, just arithmetically, 6 plus 1 is 7. So then the final answer looks like this. The final answer always looks like this, one single capacitor. Alright, so that's the answer to part A. Now part B says, what if you hook up a 30-volt potential difference, or a battery? So I will do that now. In fact, I'll just add it on to diagram A and then do the computation for diagram B. So what would it be? It would be something like this. And that would be, like, say, the positive side of the battery and the negative side. Doesn't really matter. So now I have a complete circuit. All right, and it's a 30-volt potential difference. Now, here's the basic idea in all these problems. Once you've drawn all your diagrams, it's a matter of using C equals Q over V. I'll write it in blue. What I'll be doing is just basically C equals Q over V, and this is a fairly straightforward problem. Some of them will be more involved, as were some of the ones we've already done. But you start with the simplified diagrams and work backwards all the way back to the original diagram. Keep applying C equals Q over V. That's basically the only equation we're using now. It really is. It's the only equation we're using. C equals Q over V. So for example, if I go backwards from my answer to part A and go back to this lower left-hand diagram, I'm going to be writing most of my answers on the diagram, but I'll be computing things with that blue equation over there on the right. So here's the rule. The 1.33 and the 6 microfarad capacitors are in parallel. The rule is, when you're in parallel, they have the same voltage. But what voltage do they have? Well, they have the same voltage as the one that replaces them. That's the 7.33. In other words, you carry some information backwards from the simplified diagrams, keep going back with it. In other words, the information I'm carrying back is that this thing, this capacitor up here, is a 30-volt potential difference, and this one down here as well has a 30-volt potential difference. So they each have a 30-volt potential difference. What I don't know is the charge stored on each of those. Well, basically, you go back up to that blue equation, just plug in. You have V and you have C. You plug in, and basically the end result is you're going to be multiplying C, the capacitance, times the voltage, and it comes out to be, in this case, 180 microcoulombs when you plug that into that equation, and the other one will be 40 microcoulombs when you multiply 30 times 1.33. If you want to check that, what you can do is you go to that last diagram in part A. If you would have plugged into C equals Q over V for that, you would have found here that you would have gotten 220 microcoulombs of charge on that capacitor if you take 30 times 7.33. And now we notice that the 40 and the 180 in the lower left here add up to 220. So the total charge on the two capacitors equals the total charge on the single capacitor that replaces it. That's a good check. All right, now I'm going to go from that lower left-hand diagram to the original diagram with the 3 capacitors, but I have to carry back some information. Now the 6 microfarad capacitor is already completely solved. I know its capacitance, that was given. I know its voltage, 30 volts, and I know the charge stored is 180 microcoulombs. But what about the 2 and the 4? I'm going to do them both, even though it only asks about the 4 microfarad capacitor. But here's the important thing. Any capacitors in series have the same charge as each other. What charge do they have? Well, you look at the diagram that I just came from that says that the 1.33 microfarad capacitor has 40 microcoulombs. That means that both of these have 40 microcoulombs of charge. 40 microcoulombs. So if I know their capacitance and their charge, I could plug into that blue equation over there on the right, top right of the of the page to figure out what the voltage of each of those is. Turns out that if you rework that equation, you get V equals Q over C. So these are easy enough to do in your head. You're going to have Q, which is 40 over 2. So this one here on the left is going to come out to be 20 volts. And the one on the right here, the 4 microfarads, is going to be 40 microcoulombs over 4 microfarads, gives you 10 volts potential difference. That's what they were looking for the answer. What is the potential difference across the 4 microfarad capacitor? One check here is if you take those last two blue numbers, the 20 and the 10, if it adds up to 30, that's good, because it adds up to the total voltage that replaces it in the next diagram. Another thing that you could have been asked for in this problem is, how much energy is stored in each capacitor? How much energy is stored in the total system overall? You could do that by adding up the energy stored in each capacitor, or you could go to the final diagram to get the energy stored in that 7.33 microfarad capacitor. So those are some additional questions that you could be asked.